In this video, we're going to be writing inequalities. We're also going to actually be solving them a little bit, but not fully. We'll get to that when we get to it. Evidence-wise, we're going to talk about how we connect representing solutions and inequalities. Then we're going to use our math reasoning to understand inequality and describes an infinite number of solutions. What does that actually mean? We'll see in just a second. Are there any experiences there? A lot of me talking today, and less of you doing things, but that's okay. So what are inequalities? Let's just review these real quick like. So we have 5 of them. Less than, greater than, less than or equal to, greater than or equal to, or not equal to. Less than looks like this. Whenever you're talking about one of them, always think of what is here. This is going to be less than whatever is here. Greater than then is the other direction. This is greater than this. Less than or equal to. It's just the less than sign again, but this time has a line underneath it. It's like half equal, half less than. Greater than or equal to is the reverse. And not equal to, that's one that we don't use as often, but we've been using it quite a bunch of times. It's an equal sign with a line through it, saying that's not equal to. So if you don't remember those, I think we did a video of them way back in 2.1 or 2 or 3 or something. I don't know. I'll put a thing in the corner there for you. But there you go. In case you don't remember, write them down. Pause the video right now. So how do we actually make an inequality? Let's think about this problem here. We have the number of Sherman tanks T produced during World War II is greater than 50,000. So the first thing we need to know is we need to know we have a variable. Second thing we need to know is that we have a number. And the third thing to look for is some word that tells us what inequality we have. In this case, it's real simple. It says greater. So we're going to write our T. We're going to have our 50,000. And then we just know that it's greater than 50,000, so we are going to say T is greater than 50,000. And that's it. It's a very simple word problem. Not much that you need to think about there. Yeah, it's really straightforward. Pause the video there if you need to write this down. But I don't think there's a whole lot to write down in this case. So, our you-do problem for today. You have the speed S of the bus must be no less than 50 miles per hour.
50! Stay above 50! Alright?
Take some time. Think about what are the inequalities that you have to use. What is the variable? What is the number? Pause the video. Shouldn't take you too long, I hope. Alright, so let's look at our second example here. This is more of an example of solving an inequality. So we're going to do that. The maximum speed of a Boeing 747 is 900 kilometers per hour. The inequality S is less than or equal to 900 describes this relationship. So it's saying is anything that is 900 or less can be a speed. Which of the values are possible solutions for this inequality? So all we need to do is kind of like with equations. We're going to take our inequality and replace it with each of these values and see if it's true. So, is 400 less than or equal to 900? Yeah. So, this one definitely works. How about the next one? Is 700 less than or equal to 900? Again, yes, it works. So we can include that one. How about 900? Well, 900 is not less than, but it is equal to 900. So 900 actually works as well in this case. It is less than or equal to in this case. And finally, we have 1100 here, 1100. That is definitely not the case here. It is definitely not less than 900. It is definitely greater than 900. So that one's not going to work. That means that we actually have 3 solutions in this problem, which is kind of weird because usually we only have one answer, right? So what does that mean? Let's talk about it on the next slide. So the really interesting thing about inequalities is that you have an infinite number of solutions. There's not one answer, there's not 2 answers, you have lots and lots of different answers that are possible. It doesn't mean that every value is possible. That's not what infinite means. It just means that there is no end to the number of answers that we could have. For example, in this inequality, we have x is greater than 1, so x could be 2. Right? 2 is greater than 1. X could also be 3, because 3 is greater than 1. X could be 4, because x is greater than 1. You can keep going, 5, 6, 7, 8, etc. You could keep going, and it would still be a solution as long as it's bigger than 1. You could even have something that's really close to 1, like 1.5. That is still greater than 1. You go even smaller, 1.25 is still greater than 1. 1.01 is still greater than 1. Barely, but it is. And of course, 1.000000000, I probably didn't write the right number of zeros there, 1, is still greater than 1, though it's very, very, very close to being 1. So there is an infinite number of solutions that you could have, especially when you consider all of the numbers that aren't going to be whole numbers that you could include. So kind of an interesting thing. Pause, write down a few of these. You don't need to write down every single thing I've written here. Write down a few of these. So, things to remember about this video. Use the inequality symbols to write an inequality. There are 5 of them. You just have to figure out which one you need to use, and sometimes that can be a little bit tricky. And when you're finding possible solutions to an inequality, remember that they're an infinite number. Sometimes the problem will only give you a few to choose from. That's what we saw in example 2, and you're going to see in the suggested practice problems. But really, in the grand scheme of things, there is an infinite number of answers as long as it's matching that thing. So, that's about it. Maybe pause, write these down so that you remember them, and then we'll look at our suggested practice problems. So, suggested practice problems for today, there are 5 of them. In numbers 1 through 3, you have 3 phrases. You're going to make an inequality based on them. The numbers and the variables are there. You just have to figure out which inequality do we use in each situation. 4 through 5 is going to be more like example 2. You have an inequality. I've given you a few different numbers to test and see which ones are solutions and which ones aren't. Remember, there are more than there are listed there. But we're not going to worry about that. We'll keep it simpler for today. So, pause the video, give these a try. Good luck.